welcome you and pleased to welcome John Rogers tonight in our sixth program of North Reading Reads this year. I'd like to thank the Friends of the Library for their support of all our programs. Please take a moment to look at the raffle basket. It's a green items, and consider buying tickets, which is a way to help support the library. And the Friends are now an Amazon affiliate or associate. You can go to our website. If you buy something through that particular icon, some of the percentage of your purchase will go to the library or the Friends. And I want to talk about some upcoming programs, including one for elementary school children that's related to North Reading Reads. Saturday, April 12th, there's going to be a group coming called Bug Works, and we'll talk about bugs with children. That you have to be 6 years old to participate, and you need to register for that. So, we do have two more North Reading Reads programs. Dr. Les Norford of MIT is going to talk. On Thursday, April 17th, is going to talk about green buildings. And on April 26th, a Saturday, Janet Nkosia is going to lead a walk in the woods off Foley Drive. We're very fortunate to have John Rogers here tonight to talk about climate change. And we're fortunate, North Reading is fortunate to have John as a resident. He serves on both the Recycling Committee and the newly formed Ad Hoc Energy Study Committee. He is the Northeast Clean Energy Project Manager for the Union of Concerned Scientists, helping to implement a range of cutting-edge clean energy and climate policies that the organization has helped win in the region. John joined Union of Concerned Scientists in 2006 after 15 years of clean energy experience in the private and public sectors. Please welcome John Rogers.
Thank you very much, everybody, and thanks very much to the library for the invitation, the chance to be a part of this series, which seems to have been very successful this year. I am with the Union of Concerned Scientists. Just to give you the brief version, UCS is the leading science-based organization working for a healthy environment and a safer world, and that takes various forms, a number of different programs, several of which are related to climate, clean energy, and clean vehicles. So I work with the Clean Energy Program. I want to talk a little bit about climate change. How many of you are familiar with climate change? Okay, good. Then that'll make my job easier, because I'm really not going to get deeply into the science of climate change as a whole. But I want to talk about, when you think about climate change, what are some of the images that come to mind? Anyone?
SUVs.
SUVs, okay. Some of the things that are causing climate change. What else?
Melting of the polar ice.
Melting of the polar ice. Maybe you see a polar bear swimming across the open ocean. What else?
Increased storms.
Increased storms. Right. So I'm not going to talk about polar bears tonight, and I'm not going to talk much about storm. I'll talk a little bit about storms. Some of the other images you might think about: a desert, or the melting glaciers, or low-lying tropical islands that are in danger of being flooded. Those are all very valid images and very, very real reasons to care about climate change. But what I'm going to do is talk a little bit about some of our work in bringing climate change down to earth, as it were, down to our reality here in the Northeast, so that you all can understand that even if you don't care about polar bears, and you don't care about people living in deserts, and you don't care about people in faraway countries, you should care about climate change. And what I hope you'll take away from this evening is an understanding of the challenge for the Northeastern United States, for North Reading, for Massachusetts, of climate change, both from an environmental perspective, but also from an economic perspective. The challenge, but also the opportunity. So don't leave before we get to the opportunity part, okay? Because that's the good stuff. So when you, and I welcome questions as we go along. If you have deep questions, let's save them for the end. But if they're clarifying questions, please feel free to answer. So one way to think about climate change is to think about the words responsibility and stewardship. Because if you think about it, one of the things that is most real about climate change is that the impact that it will have on our children and on our grandchildren. Because our actions today, the decisions we're making about how we use energy, about how we do transportation, about how we build our buildings, those decisions have a real impact for decades to come. And you'll see some of that in this slide. And so when I think about climate change, these are some of the images I have. My two children, I don't know who the third is, but no, that's my niece in the middle. So this is what I'm thinking about. You know, our children who are going to be growing up in a world where, as you'll see, the die is already cast for the next 30 years, just because of the way carbon works, the lag in the climate in terms of when we're putting carbon in and when it has an effect. That's really set in stone. And so what we're really talking about today is what happens when they get to be in their 30s and 40s and 50s. What does the world look like that they're living in and that they're raising their children in? So that's what I want to talk about today. So when we're talking about the climate challenge, well, I'll talk about three things. One, what it is, just in brief. Two, what it means for us. Again, bringing that from a global issue, which it certainly is, but down to a regional issue, a state issue. What does it mean for us here? And then what we can do about it. So just a quick primer on climate change. The carbon dioxide is the major greenhouse gas. There are a number of greenhouse gases, a number of global warming pollutants. Carbon dioxide is a major one. And how many of you have seen An Inconvenient Truth? Okay, a fair number of you. So you know he does some fancy stuff with his, going up on the platform and showing basically what's happening with carbon. So carbon dioxide is here on the top, temperature is here on the bottom, and what you can see is that there's a very strong correlation between the two. Going back, 650,000 years or much farther, as far as we can go back, there's a strong correlation. And it is cyclical. That's one thing you'll hear climate change contrarians talk about. It's a cycle. Oh, it's just a cycle. Well, it's true that it's cyclical. But look at where carbon dioxide is now. So since the beginning of the Industrial Revolution, we've gone way off the chart. So we're up here at 380 parts per million. Never in all this time has carbon dioxide been at that concentration. So yes, it's cyclical, but things are out of whack. And so that has implications for temperatures. Here are some folks who are studying it. This is the statistics on the Intergovernmental Panel on Climate Change. Some of you probably heard when each of the reports came out. There were a series of, I think, 4 reports last year. This is the 4th round of studies from the IPCC. Thousands of experts, hundreds of authors, 1 report. There are some summaries of it, I think, back on the table where I have some summaries if you're interested more about it. What does the IPCC say in its 4th assessment? Its strongest language yet about the human link with climate change. It says, the IPCC says that it is very likely that emissions of heat-trapping gases from human activities have caused most of the observed changes since the mid-20th century. And by very likely, what they mean is 90% chance or greater. So this is the strongest language yet that they've had. So what my colleagues did was bring together a collection of over 50 experts, mostly from the Northeast, and try to look at climate change, again, not as a global thing, but as a look at the impacts, the possible impacts on the Northeast. So make some projections about where we're headed, and then say, what does that mean for key climate-sensitive sectors in the Northeast? And they came out with this report last July. I didn't have much to do with it, but I'm pleased to be able to draw on it. This is an amazing piece of work. I have copies of the summaries back there, and there's also a Massachusetts State summary. And I'd really recommend it because this is some powerful images, some of which I'll show you tonight. So again, this is a collection of over 50 experts, economists and scientists from all different reaches that put together something called the Northeast Climate Impacts Assessment. So when you're thinking about climate change in the Northeast, the first step is to understand where we are. And the first thing to understand there is that the climate across the Northeast is already changing, that there are changes already happening that are consistent with global warming. What are some of those? Annual temperatures are up 2 degrees since 1970, almost 2 degrees since 1970. The winters are warming fastest, 1.3 degrees Fahrenheit per decade since 1970. Snowpack and lake ice are decreasing. The spring indicators are arriving earlier, so whether that's flowers or insects or ice melt. And extreme summer heat is becoming more frequent. The other thing you want to understand, the other thing you need to do if you're going to make some projections about climate change in the Northeast is make some predictions about where we're headed. That's not an easy thing for reasons I hope you'll understand by the end of this evening. But But there are various scenarios that the IPCC, the Intergovernmental Panel on Climate Change, used for its projections. And so here's the range of scenarios. So what this study did was say, okay, let's take two of them. Let's take a higher one, which essentially is kind of a business as usual, heavy reliance on fossil fuels. You know, we're still using coal, we're still using oil, all these fossil fuels, and we're just not getting our act together. The other, so we call that the higher emission scenario. The lower emission scenario is this one where it says, hey, we have a bunch of tools at our disposal. We know how to use oil more efficiently. We know how to make energy with something other than coal. Let's get our act together. Let's do that. And so that's what we call the lower emission scenario. And so this whole study looks at the difference between the higher and lower emission scenarios. So when you take those scenarios, you can start making some estimates about where temperatures are headed. So here are historical and projected temperatures for the past century and this century. So what you see is in black here is the observations, what have been the actual temperatures. What you see in the sort of brownish orange on the bottom is the temperature projections under the lower emission scenario. Red is under the higher emission scenario. So there are two things to note about this graph. One is that you can see that for the next 30 or 40 years, there's not much difference. Why is that?
We already got the problem.
So, right, the problem is already there. Those are the effects of the emissions that we and our parents have been putting into the atmosphere over the last 30 years. So that, again, this time lag in the climate system says that the die is cast for the next 30 or 40 years. But then what you start to see is between the higher emission scenario and the lower emission scenario is a pretty healthy, a pretty serious divergence, such that by the end of the century, temperatures are much greater under the higher emission scenario. What does this mean? One way of thinking about what this means in terms of temperature is how hot a summer would feel, what we call the heat index. So this is the mixture of temperature and humidity. And so this is I'm going to say good things about these graphics because I'm allowed to because I had nothing to do with it. But here's one that shows up in the report, what we call the migrating states analysis. So here's Massachusetts up in New England where it belongs. What you see is the red Massachusetts is where the state is going to be in the mid-century and at the end of the century under the higher emission scenario. What a summer in Massachusetts is going to feel like. So what this says is that under the higher emission scenario, by the end of the century, a summer in Massachusetts is going to feel like a summer in South Carolina today. So think about that. And some of you may vacation in South Carolina. It's a great place, but it's not Massachusetts. No, that's not natural. Under a higher emission scenario, under the lower emission scenario, we end up somewhere around Maryland. Now, I'm from the DC area, and it's a great place, but again, that also is not Massachusetts. So those are some of the images I want you to keep in mind as we go forward. Here's another way of thinking about temperature and the effects of the two different paths that this study was examining, is looking at extreme heat, so days over 90 degrees. Right now, we average about 10 degrees. Historically, we've averaged about 10 degrees in the summer. By the end of the century, under the higher emission scenario, we're talking over 60 days over 90 degrees in a given summer. So that's 2 out of every 3 days in the summer. Under the lower emission scenario, it's about half that. So again, a marked difference between the two. If you think about 100-degree days, right now we average about 1 in a summer. By the end of the century, under the higher emission scenario, we could be looking at something like 24. 1 in every 4 days, over 100 degrees. Under the lower emission scenario, it's only a quarter of that. So the other thing that the study looked at was changes in precipitation. That's a little harder to model, but we do know that for a variety of reasons, if you think about evaporation, you think about runoff, and what we'll end up with is more water when we don't need it and less water when we do. So paradoxically, we'll end up with more flooding and more severe droughts. So when you put those together,